the final part now wants us to solve this cubic. So it says that show a equals 1 is a root. If a equals 1 is a root, then a minus 1 is a factor. But also, if it's a root, then if we substitute 1 into here, we should get 0. So when a equals 1, then we've got 3 lots of 1 cubed, take away 5 lots of 1 squared, plus 2, which is 3 times 1 cubed is 1, so that's just 3. Take away 5 times 1 squared, which is just 1, so take away 5, plus 2 gives us negative 2, add 2, which is 0, and therefore it is a factor. A equals 1 is a root, and so a minus 1 is a factor. Because a minus 1 is a factor, we know that 3a cubed minus 5a squared plus 2 can be rewritten as that factor a minus 1 times by some sort of quadratic. Now there's 2 ways to work out the quadratic here. We can guess most of it. For example, we know that this is going to be a 3a squared to make 3a cubed, and we know we're going to need a negative 2 at the end to make a positive 2 when these 2 terms get times together. And then we just have to use equating coefficients to work out the middle term. Sorry, I should not use an a there, because that's this value here. So let's write, say, a p, and work out what the value of p is to get the quadratic. Or you can use polynomial division. Now, I think it's quicker to do the equating coefficients method when it's just a cubic, but when you move on to C4, polynomial division is quicker because you get higher powers. So I'm going to continue with this method to work out the value of p. So the equating coefficients method, you say, well, we look at one of the powers, and I'm going to look at the a squared power, and we know on the left hand side the coefficient of a squared is negative 5. Now it needs to be the same on the right hand side if these 2 things are going to be equal. So we look at what's going to give us an a squared term, and I'll get an a squared term here, so the p will contribute to the coefficient of a squared, and I'll get one here as well, so the negative 3 will contribute to the a squared coefficient, and then that tells us that p, if we add on 3, p must be negative 2. So 3a cubed, take 5a squared plus 2 can be written as a minus 1 times by 3a squared minus 2a minus 2. So we go back to the question. It says, and hence find the other possible value of a, giving your answer in simplified form. So that tells us that the simplified surd part tells us that this doesn't factorise. So in order to solve this equation, you can either complete the square or use the quadratic formula. If we use the formula, we'll get that a is minus b, so that's positive 2, plus or minus the square root of b squared, so that's 2 squared, which is 4, minus 4 times 3, a times minus 2, all over 2a, which is 6. So that's 2 plus or minus the square root of 4 plus 24 over 6. So that's 28. And this does simplify a little bit because root 28 has got a square factor in. So we can take out the square factor which is 4. So we can write that as 2 root 7 over 6, and then we can divide by the factor of 2 that's on the top and the bottom and write that as 1 plus or minus root 7 over 3. And then those are potentially 2 possible values for a, but if we go right back up to the top again, it says that a is a positive constant, so we can't have the 1 minus root 7. So a is 1 plus root 7 over 3, since a is positive.